了，谁是面试官啊？我要跟面试官互动的。
I will be your interviewer today. So hi.
Okay. Hi.
So let's say I give you a matrix. Each matrix they have an equal number of rows and columns, and then I want you to find the k smallest element in the matrix.
Okay.
Do you have any questions?
Yeah, I kind of understand this problem, but I'd like to ask some questions. So what's the minimum value of the n here?
Minimum value of the n, that would be 1.
1. Okay. So what's the range of the k?
The range of the k would be bigger or equal to 1, but less or equal to n squared. And also I can tell
Okay.
you the range for n is inclusively between 1 and 300.
Okay, got it. So the
And
k. Mm-hmm.
yeah, you can take some notes.
Okay.
And then each element inside the matrix, it was between the -10 to the 9 power of 9 and the 10 to the power of 9. So it's pretty large. It could be pretty large, I would say. And
Okay.
also, I can give you a feature of this matrix. Its matrix, its column and rows are sorted in a non-decreasing order.
Okay.
In a
Which means
non-decreasing, so which means it could be have some duplicate, but it is the guarantee that it's non-decreasing.
okay, got it. So we can return some element because the key is less than n squared, right? Okay, so I think now I pretty much understand it. So can I make some comments why
Yeah,
I work
you can
through?
do it whatever you like.
Okay, so the input of this question is we have a matrix which the row and column are sorted in ascending order. And we also have a int k, which means we will find the k smallest element in the matrix. And output is also int, which is the element, which is a k smallest element in the matrix, right? Okay, so one solution I think is since we should return the element of the matrix, which means it is included in the matrix. And the range for the answer is from the minimum value to the maximum value of the matrix, right? And then we can, so for each element in the matrix, we can use a helper function to count how many elements are smaller or equal to this element, right? And then we compare the matching result to the k. If the result is greater or equal to k, we will find a smaller element, right? Because it is larger than k. So otherwise, we will find the larger element. And since the element we return here is of a range which can be a sorted array, which is sorted. So I can do binary search to improve the efficiency to make it log n as a time complexity.
What is a previous idea, like the time complexity for your previous idea for the helper function?
So if we use loop to do it, it is n squared because it is a 2D array. So for now, if we use the binary search, we array
Sure.
search, we cut it. Oh, okay. So it's from n squared to login. And for the count, also if we use loop, it is also n squared. But now I can think of another way to do that. So since the rows and columns are all sorted in ascending order, so which means if we start with the bottom left corner, so let me make the matrix now. I will take the first one as the test case.
Mm-hmm.
So since the rows and columns are sorted in ascending order, so if we start with the bottom left corner, if we want a larger element, we will definitely go to the right side. And if we want the smaller elements, we will go to the upper side, right? So like, so for now it's 12. If we want 13, 14, 15, or some larger one, we will go to the right side.
Mm-hmm.
If we want a smaller one, we will go to the upper side, right? And then we can, so for this way, we can do it in n. The time complexity will be O(n) because so for array compare, we can just move the column pointer or the row pointer. So it is a square. It is n squared. So the time complexity for that is O(n). So like let's take an example. So for if we want to count for the 12, and the k and the target is.
You wanted to find the k smallest element in the matrix. That means.
Yes, we will count how many elements are smaller or equal to 12. So it is 1 plus 10. So if this one is greater, if this number is less than the target, less than or equal to the target, we will count all the number before that. So any number for now. So like we just want to compare the result of it and then compare to this k. So for the helper function, we can just return the number of elements which smaller or equal to this one. So for the 12,
so in this case, you are telling me there will be 5 elements smaller or equal to 12, right? In this example.
Yes. And then if we okay, so and the target in this helper function is from the array, here. So here in the first example means 1, 2, 3, 4, 5 to 12, right? And then we use binary search to pick one as the target for the helper function. Okay. And then we will count. So the target here, so the target is from here, and we count for this.
I got what you mean. So you wanted to pick one number from the minimum and maximum range, and then you're trying to find, like inside the matrix, you're trying to find if this one is inside the matrix, and also the element which is how many elements is smaller or equal than this number, and then you kind of like match it with k. If you find that like this result is greater or equal to k, then you can make it smaller, and then you just wanted to find the results which equals to k.
Yeah.
I
exactly.
See.
So I can.
I think I got your idea, and why not you just go ahead and do your code.
Okay, I can start code now.
Yeah.
So because the n here is starts from 1, so we don't need to do the corner case to check if it is 0 or something like that. So we can just do we can just count the length of the matrix, which is n.
Mhm.
And then we find the minimum value and the maximum value of the matrix as the range. Oh, sorry. I will call it as left and right.
Mhm.
And then I will do the binary search. So while the left smaller or equal to right. First, I will find the medium midpoint. So which is left, right, y2. And then I define a count to store the result of the helper function. We just call it helper. And so for this one, because we need to find something in the matrix, so we will put the matrix as the first index and the middle one, midpoint as the target. I will finish the helper function later. So and then
Sure.
if the count is greater than k, which means we should find the smaller one, right? So it is right because we and else we turn left plus 1. And then because another thing I want to mention is that so because this is a range, right? We take some element in from it, but some of it doesn't include it. Is not included in the matrix, like the 14. So for the 13, we can say that there are 8 elements smaller or equal to this one, and for the 14 we also have 8 because we don't have 14, right? If I have 14, it should be 9, right, instead of 8. So it is like find the first target, right, greater or equal to the k here, right?
If you have 14 as your selected candidate, would that be not in the matrix? So like you cannot really find that one because
Yes, that's
14
why.
is not inside the matrix,
Yes,
right? So you need to find the 13.
That's why we need to find the first element which has the same result.
Element which has the same result.
So because the 14 is not included in the matrix, right? So it is still 8. If we have 14 in the matrix,
well, why not?
It should be 9.
Why not you? If it's kind of like if 14 is not in the matrix, why not you just give it like an integer maximum, like a maximum of the integer? So like that means you cannot find it inside the matrix, or
yes, but in that way we don't know if we don't have a if we don't have a result to return, we can't know which way we will go. So to the left or to the right, we don't know, right? So if it just return -1, and then which way we should go? If it is a first target, like we have 28 numbers here in the range.
Yeah, I just kind of like checking, just do a check, maybe do a check, but you probably maybe unnecessarily. So you say you wanted to find the first element, like this first element, is that what you're saying, like after the while loop, or any, or inside the while loop, as long as you have like a same element with the same count, then you kind of like wanted to find the first element. Is that what you're saying?
Yes. Because for the 12, we only have 7, right? We only have 7 elements smaller or equal to this one. and for the 30, we have 8, and for the 14, we have 8. So our target is our goal is to find the first one, which is greater or equal to the k here, because we will find the k's smallest number. So for the 12, we only have 7. We don't know which is the next one. So we will go to the, we will find a larger one for that, right?
Right.
Okay, so
now you are out of the while loop.
Out of the while loop.
After you've done the
yes,
while loop,
because I'm going
then...
to do the helper function and then come back to return something.
Why not you just finish the main body, then you can finish the helper function?
Okay, so because we are going to find the first one.
So right
like
now your right and left, your left is bigger than right. So that means in this case, the left will be 14, the right will be 13.
The what?
For this example, when you're out of your while loop, that means your right is bigger than left, right?
The right, no, the right is less than left.
Yeah, the left is bigger than right. Okay, so in this case, you are
so it will stop at this index, right? So the
why you will stop at this index?
Because if we find the 8.
Oh yeah, I saw. I think I know what you mean. Yeah.
Because
Mm-hmm.
So if the left, let me see. So if we found 14 is great, is valid, so then we go to a smaller one, right? And then we found 13 is also valid one. So the 13 will be the left, right? And also the 13 is a midpoint, and then we still go to the smaller one. So that's why the right is less than the left, which is 12 now. So what we want to return is 13, so we return the left here. So can I do the helper function now?
The helper function, okay, sure, but I think your helper function is just like a counting, right?
Yes.
Yeah, so you can do it.
Oh, okay. So we should return int, we just call it helper. The argument is matrix and int target. So we will find how many elements is smaller or equal to the target. So let's define a count. And then we'll do, we can start with the bottom left corner. Let's define I as the row, which is matrix.length -1, and the j as the column is 0 here, right, for the 12. And then we will use the 2 pointers if the I is greater than or equal to 0 and j is less than matrix.length. So we make sure it is inside the matrix. And then if the matrix ij is smaller or equal to target, so we know that's what we want, right? And what should we add is not 1, it is I plus 1, which means in this column we will add all the elements before the matrix ij, right? So the matrix ij row is I. So there are I plus 1 numbers is smaller or equal to this one. So that's why we add I plus 1 here. And then we will go to find if there are other elements greater this one, smaller this one. So we go to the right side because we have count for this column. So we'll go to the right side, which is I plus plus. Else, if it is not, we will go to the upper side. If the matrix ij is larger than the target, we will go to the upper side to find the smaller element, which is I minus, and then we can just return a count. So that's a helper function. And do you want me to do a test case for that? Or it is okay?
Let me. How many times do you got left? Like how many minutes? Sure, you can do a short test case and see. One thing I'm not quite sure about is when you're counting the target, like how many elements is less or equal to target. Why did you do like a count plus equals to I plus 1 again?
Oh, because if the matrix is smaller or equal to the target, it means this number is what we want, right? Because the row is
what number is
sorted
what
in
we want? The matrix
so for
INJ?
so we start with the 12 here, right? The bottom left corner. And then if it is smaller than the target, like if the target is 13 now, right? We just take it as an example. So if it is smaller or equal to 13, that's what we want, right? We will count how many elements in the matrix is smaller or equal to 13. So the first one is 12. It is smaller than 13. So that's what we want. Because the row is sorted in ascending order, so all the number before the 12 in the same column will be counted. So that's why the time complexity is O(n) instead of n squared.
Oh, you sort of do it optimized based on you are not counting like the matrix one by one, but like you started from the bottom left and then you count the number smaller or equal to the target.
Yeah, so for now, if we count how many numbers are smaller or equal to 13, so the first one is 12. So okay, 12 is less than 13, and it is sorted in ascending order. So 1 and 10 must be smaller than 13. So that's why we add 3, and we go to the next column because we have counted for this one, and we can say, oh, okay, 13 is smaller or equal to 13, which means all the numbers before that is valid. And then we plus 3, and then we go to the next column. 15, okay, it is not. So if it is not, we will go to the upper side, like I minus to say whether there are some numbers is smaller or equal to 13. And we when we go to the upper side with the number now is 13. Yeah, we got 2. So that's why it is O(n) time complexity.
And then you have an A in the count, and when your mid is 13, your count is 8, and then in this case, I'm talking about your first example here. So A is greater or equal to number K, which is number 8, then you kind of like move your right pointer to the left. Then that means your right pointer is now smaller than your left pointer, and then you kind of like exist this while loop, and then you just return your left pointer, your left pointer, which is in case it's kind of like on the right range. I mean, yeah, okay, I see. Yeah, I think you are doing well. And I really love the the counter mechanism. If you do the normal counting, that will kind of like bring the time complexity to n squared.
Yes.
So then there's no point of like using binary search anymore. But yeah, I really love it. One minor point is on the 14, you kind of like misspelled the length, but it's LENGTH, not the HT
14?
on line 13.
Oh my god.
Yeah, just a little typo, but doesn't matter.
Thanks.
Yeah, so I think you did great.
Okay, so 你不问我总的那个 time complexity 了吗？我还没说呢。
其实就已经大概，那我问一下吧，你大概要多少？对，你是 O(n) 加 n 加 log n 嘛，就等于 n log n 嘛？
是log n 乘以 n， 因为那个 binary search 这是 log n， 然后每一个都是 n， 然后所以就是 n log n。
对 ，OK。
哎，但其实我说实话，我觉得我自己还没有完全讲清楚这个，我要回去再想一想，到时候怎么讲这个东西。
我有一个
突然返回了一个，你说，
就我这个地方没有懂，就是